Hello everyone and welcome to the School of Solana Season 6 Lesson 1. Yes, this is already the 6th cohort of this course. And for those who don't know what is this course about, so in the school we onboard new people and also new developers to the Solana ecosystem. There is plenty of lessons you can look forward to. So, for example, you will learn the Solana fundamentals, you will learn how to create new programs in Rust and also how to create new Solana programs in Rust. And we have a bunch of other lessons, for example, security, front-end, and also some guest lessons. As I said, this is the first lesson. So in this first lesson, I will talk about the introduction to this course. So you will learn where you can find various stuff, for example, materials, tasks, and so on. And in the first week, we will cover some Solana fundamentals and you will learn important stuff from blockchain in general. My name is Andrei and I'm going to be a lecturer during this cohort. My position at the key is auditor and I'm also sometimes developer. You can see my Twitter handle, but on Discord I use the same handle, so feel free to reach out to me. That's all from my side, and I have the second person here that would like to introduce himself and tell you more about our company, who we are and what we actually do. And that's Joseph, our CEO. So yeah, Joseph, it's yours.
Hi everyone, my name is Joseph. I'm the co-founder and CEO of Aki Blockchain Security, and I'm very happy that you decided to join our School of Solana Season 6. And I'm so excited about this season because so far we are hitting the all-time high in the number of applications and accepted students. We have accepted more than 1,200 students. If I compare it to the university where I teach, this is the whole first grade at the Czech Technical University in Prague. So thank you very much for joining the school. And I must ensure you that this is the best place where to learn about Solana. It's not going to be very easy. We are not giving the graduates their graduation NFT for free. You have to do some work here, but if you catch up, you will be one of the graduates of this series of courses, which have gained kind of high reputation in the whole Solana ecosystem. And maybe you are not familiar with Aki. So what we are doing, we are a blockchain security company. We are security auditors. We are auditing on Solana and also EVM chains. But our passion is also in building open source and teaching about crypto. And this all is possible only thanks to the clients that we can work with. So selected clients from the Solana ecosystem that we are really happy that we could be working with is Wormhole or Helio. But we also are quite active on the EVM chains where we work with Lido or Axelar or Safe. And also I must highlight the support of foundations we are getting. So whole this school would not be possible without the grant we got from Solana Foundation. So thank you, Solana Foundation, for supporting the Solana School. And I hope you enjoy that and see you on some of the lectures.
Thanks, Joseph, for the introduction, and now we can continue to the first lesson. So what is this course about? As I mentioned, we have plenty of lessons for you. So it will start with the introduction to the Solana and blockchain, that is the first week. Then you will learn how to create programs in Rust. Then in the third week, we will apply the Rust experience to the Solana programs, as Solana uses Rust for the smart contracts. So we are going to have 2 lessons about programming, that is Solana Programming Model 1 and Solana Programming Model 2. And then the remaining lessons are going to be about best development practices and debugging, so how to actually debug your Solana programs. Then we have lesson about the security, and last but not least, we have the lesson about the front end on the for the Solana programs. As I mentioned, we are going to also have the guest lesson, and we have already a bunch of bonus lessons. So these are only the main lessons for each of the week. This course is about also the YouTube lessons. So we have prepared YouTube lessons. You can watch the premiere or you can watch them later. We have also prepared programming tasks, and we would like to increase number of people in the Solana community, as we like Solana, so we hope that you will like the Solana too. So we would like to increase the number of people, new developers that are in the community. Developers and auditors from our company are going to be ready to answer your questions in the dedicated Discord channels, so feel free to ask anything you would like to. And then we have also prepared learning materials for each of the week, and we also prepared the Solana Handbook. Last but not least, this is maybe the most important thing you can look forward to, and that's the Solana project. So at the end of this cohort, you will create your own Solana program, also with the front end. So feel free to deploy it to the Devnet or mainnet. You can also deploy the front end, and your application can be actually used by the other people. What is this course not about? And we won't teach you how to get rich in 9 weeks. And this is not going to be also about advanced stuff. So for example, about advanced security. And that's because for the advanced stuff, we have, for example, Solana Auditors Bootcamp, where you can find more about the security. Now we can move to the prerequisites. There are a few nice to have things we think might be really helpful. The first one is basic experience with CLI or command line interface, so this can be really helpful during the course. Then at least some experience with Git, so I think during the course you will need git clone, git commit, and git push. So if you are familiar with these 3 commands, I would say that's enough. Then at least basic experience with different programming language than Rust, but obviously if you have some experience with Rust, that's awesome. But it is nice to have also experience with different programming language, or at least one programming language. It is because if you know, for example, C, C++, Java, Python, then even though the syntax of Rust might be different, still you will learn the second programming language much more faster than if you do not know any programming language. And last but not least, at least basic overview of what blockchain is. So you do not need to have deep understanding of Bitcoin, Ethereum, etc., but at least have the overview of what the blockchain is, what the blockchain term means. Now let's move on to the tasks and materials. For this course, we prepared a bunch of tasks and the materials. I will start with the materials, so you can see the QR code. This QR code, if you scan it, it will lead you to the School of Solana GitHub repository, which is stored under the Eki blockchain GitHub. And these materials are dedicated to the lessons. So what is presented on the lesson, you will find materials for that content in this GitHub repository. The second thing, the tasks. We prepared a bunch of tasks for you to complete. And the distribution of tasks is as follows. So not every week contains a task. This is because some tasks might be more advanced, might need more time to complete. So that's why there is no task for each week. That's the first important note. The second important note is that the tasks are going to be shared through the Discord. So every Wednesday, when the lesson link is shared, also the task link is going to be shared. And if you open the task link, this is actually the invitation link to the GitHub Classroom. So if you open the task link and accept the assignment, that means the GitHub Classroom is going to automatically generate a repository for you where you can work on your task. You can commit changes here, or sorry, there. You can push changes there, and actually you can push your submission of the task there, and we will evaluate it. Currently, the rules are as follows. So from all of the tasks, you can miss. This is really important. So from all of the tasks, you can miss not more than 2 tasks. This means if you do not pass 2 tasks, you can still graduate. But this rule is or cannot be applied to the Solana program, as I was talking about the Solana project, the big program that you will create during the course. You, in order to graduate the course, you need to finish the Solana project. So, but yeah, you can, for the smaller tasks that you should done or that are dedicated for the lessons, for the week's lessons or the week's content, this rule is applicable. That means you can skip 2 of these tasks. Let's now continue to the Solana Handbook. We at Eki, as auditors and also Solana developers, we are authors of the Solana Handbook, as we would like to also share our knowledge that we learned during previous months and years. Yeah, and for this purpose, as I said, we created the Solana Handbook. This is also learning material for the, I didn't want it to mention it as a material in the materials part, but this is also learning material for this course, for the School of Solana. Actually, the task 1 is about the Solana fundamentals. So everything for task 1 you can read, you can learn in the Solana Handbook. That's the first point. The second point, the handbook is also the site is publicly available, but also the source code is publicly available on our GitHub of Eki blockchain. So if you would like to contribute, just feel free to create pull request, mark our team as reviewers. We will go through the pull request, and then eventually you can be contributor to the Solana Handbook. Last but not least, you can see the QR code. So if you scan the QR code, it will lead you to the Solana Handbook. So I think that's everything from this point. And now we can move to the introduction to Solana. I think small recap might be actually helpful. So yeah, every week at Wednesday, you will see the new lesson. Some of the weeks contain tasks, but the tasks are distributed using the Discord. They are going to be shared basically in parallel with the lesson links. You cannot miss more than 2 tasks, but this is not applicable to the Solana project, to the big Solana program that you will create during the course. So in order to successfully pass the course, you need to complete the Solana project. Then if you would like to scan the QR code again, just move the video a few seconds or minutes to the back, and you can scan the QR code to the main GitHub repository that contains materials for the lessons. And I was speaking about the tasks, and also we created the Solana Handbook. That is again one of the learning materials for the School of Solana, but also for Solana in general. Hopefully you understood everything. If no, just feel free to ask on Discord, and I would say now we can continue to the introduction to the Solana. Solana was founded by Anatoly Yakovenko in 2017, and actually the nice guy in the picture is Anatoly. And then the mainnet beta went live or was released in March 2020. So currently Solana is old 4 and a few months, 4 years and a few months. The main token is Sol, and Sol can be again, or we can refer to it as also as Solana, but Solana is the name of the blockchain, so better is Sol. The small units of Sol or Solana are called lamports. And in order to understand lamports, I would say you already understand this from the, for example, Bitcoin perspective, where you have Bitcoin and you have Satoshis. I'm not sure how many decimals Bitcoin has, but Solana has 9 decimals. That means lamports, or in order for lamports to form 1 Solana, you need 10 to the power of 9 lamports in order to form 1 Solana. And it is useful if you want to split Sol into, for example, 0.5 Sol. So that means you need particular number of lamports. So that's why you actually have decimals. At the time of this presentation, currently Solana has 1,379 validators. I also linked the source, so you can check the solanabridge.io. I think there are multiple important information in the source, so I definitely recommend you to checking the page. And the next thing about the validators is the Nakamoto coefficient. So what the Nakamoto coefficient is, for those who don't know, the Nakamoto coefficient or Nakamoto number is actually the number of biggest validators that can act collectively in order to halt the network. So what does that mean, number of biggest validators, obviously? So you would need to take 19 by stake, the biggest validators on Solana. And in order to be able to halt network, you will need to persuade these 19 validators to act collectively and, for example, to stop working in order to halt the Solana network. If you open the nakaflow.io, you will see Nakamoto coefficients for different branches. So I do not want to make any comparisons here. Some people like the Nakamoto coefficient, others don't like the Nakamoto coefficient. So check the source and make your thoughts by yourself. Obviously, some blockchains have bigger Nakamoto coefficients, some blockchains have smaller Nakamoto coefficients. So I would say 19 is, at the current state of the blockchains, is pretty all right. And then, as I was talking about the lessons on the Rust programming language, so Solana actually uses Rust as the main programming language for the smart contracts and also for the blockchain. These are the basic facts of the Solana, and now we can move to the quick description that I created for the purpose of this lesson. So I like to refer to the Solana as decentralized, globally synchronized state machine. This, even though the words might be unfamiliar for you, I think this is really, really simple to describe. As I was talking about the validators, there are also some other nodes, for example, RPC nodes. But as I was talking about the validators, imagine this. You take almost the 1,400 validators and you duplicate software on each of the validator, each of the node, on each of the 1,400 nodes. As you duplicate the software will be the same. And what Solana actually does is that if you do one change on one validator to the software, to the program, this change is also done to other validators. That means they share globally synchronized because every validator has the same state. As I said, if you make one change to the software, the change to the software is also propagated to other validators. So that's why they have globally synchronized state machine. And the decentralized, so again, Solana has 1,400 validators. That means this state machine is decentralized. It is not stored only on one validator or in one data center, but it is decentralized between 1,400 validators. So that's why the Solana can be referred to as decentralized, globally synchronized state machine. I understand that, for example, you may ask, but wait, the Solana is blockchain. Why do we have some kind of state machine and software and computer here? That's true actually, but in the terms of the Solana that supports more sophisticated smart contracts, not only simple transactions that are stored on the blockchain. So Solana actually utilizes blockchain, but apart from storing simple transactions or simple transfers on the blockchain, for example, Alice sent Bob 10 BTC or Bob sent Yana 15 BTC, you store on the blockchain more sophisticated transactions. These transactions, maybe this is already a really deep technical description, but these transactions are stored in the blocks form the blockchain. But as I said, these transactions are more sophisticated transactions, and actually, as I was talking about updating the software on one validator, these transactions actually contains instructions that update the software on one validator. But the thing is that these updates are propagated to all of the validators, so each software on each validator is synchronized or has synchronized state, because each validator executes these instructions that are in the transactions, and transactions are actually stored in the blockchain. So hopefully you understand it. If no, feel free to ask on Discord or feel free to play it again. And yeah, let's now continue to different basic concepts, but these are more technical. Solana, as its consensus mechanism, uses proof of stake, and I think you may know proof of stake from the Ethereum perspective, or you may know different consensus mechanism. For example, proof of work, which is used on the Bitcoin. I have also important information here, and that's the proof of history is not consensus mechanism. It is mechanism. You will learn this in the Solana Handbook, or if you need some clarification, again, you can ask, we can discuss on the Discord. But the proof of history is just the mechanism how to synchronize time on the validators, or synchronize the sequences of transactions on the validators. But don't be afraid. Definitely don't be afraid. You will learn, or you can read this in the Solana Handbook, where it is better described. So don't be afraid about this new information. Then I have transactions per second. So Solana has 800 true TPS. What does it mean, true TPS? So I would say on the Solana, two types of transactions can happen, and one type is vote transactions, and second type type are non-vote transactions. And the non-vote transactions are actually true transactions in this statistics. That means the vote transactions are sent by the validators to each other in order to agree on the latest block, and non-vote transactions are sent by users, bots, basically users of Solana. So that's why this metric is actually modified to display true transactions in order not to consider the vote transactions sent by the validators. But if you open, for example, this information is taken from the Solana FM, but if you open any other Solana Explorer, I'm thinking about Solana Explorer, I think, you will see the higher number of transactions per second, approximately, I think something like 2,500 or 3,000. And these transactions also consider vote transactions sent by validators. Then the block time is 400 milliseconds. Just I would like to mention here that I like Bitcoin. Okay, this is not like I would like to compare it to the Solana or something like that. Just the comparison, Bitcoin has 10 minutes a block time. That means Bitcoin creates new blocks in the blockchain every 10 minutes. Solana creates new blocks in the blockchain every 400 milliseconds. It is approximately because it can be 432, for example. Then we have time to finality, which is approximately 12 seconds, and this information, or this is more technical term, time to finality, and it is because on every chain, or not every chain, because I do not want to say every chain because I do not know every chain, but it is applicable also, for example, to the Bitcoin. If new block is created, basically that does not mean that the transactions that are in the block cannot be reverted. In the case of Bitcoin, it can happen if the fork occurs and the fork chain is actually the longest one. Then the longest one chain is actually accepted as the main chain. So all of the smaller chains are reverted and not accepted. Something similar can happen on Solana, and there is the time to finality of 12 seconds. So after 12 seconds, you can be almost 100% sure that your transaction won't be reverted. Then, as I was talking about the validators, we have actually 3 networks that you can execute the smart contracts on. You can look at it as 3 blockchains. The main one is the mainnet. This is where you hold your Solana. This is where you hold your meme coins. This is where, for example, you try to trade on pump.fun, for example. And that's the mainnet. On Devnet, you can obviously also hold Solana, but the Solana there is basically worthless, as you pay the Solana here only for the smart contract deployments and so on. You cannot use, for example, the Devnet Solana for paying in the store and or transferring or buying NFTs and so on. And same goes for the testnet. And you may ask, why do we have these two chains? This is important in order if you would like to test your Solana programs before going to production, before deploying to the mainnet. So testnet is dedicated more to the mainnet features. So if there is any kind of new feature coming to the mainnet, then it is firstly tested on testnet, and the devnet is meant for the developers. So you will basically learn this in this course. You will create the Solana program. This is basically the workflow, the development workflow of the Solana programs. You create the Solana program, you deploy it locally, you test it locally, then you use the devnet to test it on devnet, and then you deploy to the mainnet, which is the production. last but not least, on Solana, we have two types of nodes. First type are the validators, and the second type are the RPC nodes. The biggest difference between these two is that validators vote on the consensus, on the proof of they need to stake some amount of Solana in order to vote for the blocks created, and RPC nodes do not vote on the consensus. So this is the only thing you should remember from the difference between validators and RPC nodes. But yeah, for example, both have the latest state, in most cases, the latest state of the Solana blockchain, as there might be some errors that occurred, for example, on some RPC node, then it won't include the latest state of the blockchain. But yeah, in almost all of the cases, they both contains the latest states of the blockchain. But the recap, RPC nodes do not vote on the consensus, validators vote on the consensus, vote on the latest blocks, vote on the correctness of the latest created blocks. All right, so these were basics of Solana. I hope you learned something new. I would like to tell you that don't be afraid if you hear a lot of new information. Firstly, we are here to answer your questions and to teach you how the Solana works, because we like Solana. The second thing is that as we created the Solana Handbook, I would say all of the stuff that is described here, or that was described here, is also included in Solana Handbook. So if you do not understand anything, try to read it in the Solana Handbook and try to ask us on the Discord, and we will definitely answer your questions. So looking forward for your questions. And now let's move to the Solana's 8 core concepts. Anatoly actually introduced 8 core concepts with the Solana blockchain. And first of all, I won't comment every core concept that is mentioned here. Again, you can read it in the Solana Handbook. But these 8 core concepts that were introduced by the Solana are proof of history, as I was talking about the agreement of time, then Tower BFT, Byzantine fault tolerance, then turbine, which is block propagation. So when one of the validators actually execute the transactions which will modify the state, then he needs to send the block to other validators so they can vote on the block, and then they can also process the transactions that are stored in the block in order to create the synchronized state machine. Then we have Gulfstream. This is different from other chains. For example, I think, I don't want to say this definition, but on Ethereum, for example, you have it is referred to as mempool, which contains unprocessed transactions, I think. On Solana, we do not have this solution. On Solana, every transaction is actually signed by the user, and then the transaction is forwarded right to the validator, which is at the time selected as the leader, and each of the transaction is forwarded to the leader, and leader processes the transaction. So there are no mempools. Then we have the C-level runtime, pipelining, Cloudbreak, and archivers. Once again, every of these core concepts are described in the Solana Handbook, so please check the Solana Handbook, read about the core concepts, and then come to the Discord and we can discuss stuff. What I would like to focus more, however, in the second half of this lesson is the Solana CLI and the development or dev environment. So I will share you my screen and I will show you some important or interesting command line commands that you can utilize during the learning process of Solana. So let's jump in. For the purpose of the School of Solana and also for you students and the future developers of Solana programs, we created Docker image with already all of the installed required packages, dependencies, CLI commands. So in this case, we are talking about the Rust, we are talking about the Solana CLI, and we are talking, for example, about the Anchor framework, which you will learn later on in this course that this framework is pretty helpful and used a lot for the Solana programs. As you can see in the screen, you can see the Visual Studio Code, which is actually included in the Docker image. And I can type, for example, Solana command, and you can see the help message of the Solana command. So there are plenty of subcommands available. And then, as I said, we have installed Anchor. So we'll also provide help message. And if I type, for example, Rust, or sorry, it is a Rust C or Rust app in this case, you can see we have also installed Rust. So I do not, or I won't go through all of the possible Solana commands, and I won't touch, maybe I will show you how to initialize new Anchor project, but I won't touch the Anchor command and also the Rust command. So in this lesson, I will show you how you can use the Solana CLI command. So let me clear the terminal. And all right, so maybe one thing I would like to mention, if you decide not to use the Docker image in the School of Solana repository, I was talking about this in the tasks and materials page or slide. In the School of Solana repository and lesson 1, you can find the whole setup, all of the dependencies, all of the packages that you need to install in order to be able to do the same stuff as I do, or you can download the Docker desktop and you can pull our prepared Docker image and then you can run it or start it and stop it. Everything you do in the Docker image, it will be obviously stored locally for you. So if you start the Docker image, then you can stop the Docker image, and then, for example, next day you can start it and you can start it again, and the stuff you was working on will remain in the Docker image. So you have actually two options. One is to set up the environment by yourself. The second option is to use the Docker image. First command I would like to talk with you about is Solana config get. So if you specify this command, then you can see the output is RPC URLI. So it tells us that we communicate with the mainnet. I was talking about the clusters. So we have 3 clusters: Devnet, mainnet, and testnet. Later on, you will see we will do stuff on the Devnet, as we can airdrop Solana, for example, on the Devnet in order to practice stuff. So that's the first important point. And the second important point is the key pair path. So as you should be familiar, on Solana, you have public keys, which is basically address of your wallet, but the corresponding public key needs to have, in most cases, you will learn that there are on Solana addresses called program-derived addresses, which do not have private keys, but the regular key pairs actually contains private key and public key. In this case, the key pair path is path to the private key. So you can, for example, sign transactions, as you will see later. I will show you, for example, how to transfer actually Solana. So in this case, we should be able to see what is our balance or what is our address. So I can specify, and you can see I've got error, no default signer found for Solana for this path. That means, as this is freshly initialized environment, there is no key pair yet, there is no private key, so we will generate one. In this case, you can use command which is called Solana keygen or keygen new, and if you do not specify any other arguments, this will by default generate key pair in the root.config, then Solana, and then id.json. So if you press enter, you can press enter a second time, and right now if I use Solana root address again, you can see that it already showed me some random letters. This is actually my public key. Right now, for example, this is my public key and this is on mainnet. So right now we would like to work with some Solana. So first things first, in order to work in development environment, we won't work on mainnet, as that would need, we cannot airdrop Solana on mainnet, we cannot create Solana on mainnet. That would mean I would need to buy Solana actually and to send it to this wallet address. So I will modify the config, or I will modify the Solana CLI command to communicate with Devnet, not mainnet. So let's do this. So we will use Solana command, then config. As you can see, I was using config get, but in this example, or in this case, we have config set, and then D, which stands for Devnet. If you use M, for example, that stands for mainnet, or T for testnet, or you can use also L for localnet. So let's hit enter. Okay, you can see that RPC URI changed and we are currently communicating with Devnet. And right now, as I'm going to airdrop some SOL to my wallet address, it is important that key pair is set to this path, which is actually private key, or which is actually key pair of the address that was printed here. So what I can do now is specify, for example, Solana airdrop 5. So this command will actually call airdrop instruction and we will receive 5 Solana. You can see the signature and you can see the output 5 SOL. So currently, if I specify Solana balance, you can see that I have 5 SOL. What is maybe really nice, that you can also see on this on Explorer, on Solana Explorer. So just copy the signature, navigate. I'm using explorer.solana.com, and don't forget to change or from the mainnet beta to the Devnet cluster. And take the signature and paste it here. Okay? And you can see basically that the transaction was successful, and you can see that we received actually 5 Solana here. This transaction inspection is really important later on for you to actually inspect, for example, more advanced transactions on Solana. If you, for example, invoke your Solana program, you can see that what was invoked, what are the accounts on the input, and so on. But for now, we are just playing with it. So let's go back to the Docker image. So right now we have 5 Solana, we are on Devnet, and for example, we would like to transfer Solana to our friend. Maybe important note to mention, the behavior is basically similar, or it is the same behavior as on mainnet, even though, yes, we are actually on Devnet, so that means we can practice stuff, but on the mainnet it is the same, okay? But on Devnet, we can airdrop Sol. On mainnet, we cannot airdrop Sol, so that would mean we would need to actually buy the Solana. So in this case, as we are just practicing, we can use Devnet, but the same behavior is on mainnet. So let's create new wallet address, new key pair, for example, for our friend called, let's say, Eki. So again, I'm specifying Solana keygen new, but in this case, we do not want to overwrite the default key pair, but we would like to create a new one. So we can specify O and eki.json, which is the output file of the key pair or private key. Again, double enter, and you can see that we already have created this JSON file, which is actually byte array of private key. Now, as we want to send from our wallet, we want to send Solana to this wallet, we need to know what is the address of this wallet. So we can do Solana keygen, but not new, but pub key, and specify the file. Voila, we see the public key of the wallet. If I take the public key and use Explorer, you will see that the account is actually empty. So because we just created the account does not have any balance, any Sol. So we are going to send Solana to this account. So let's do that. Okay, so we need to specify Solana, transfer, then the wallet address, then I want to send 1 Sol to this wallet, so I need to specify 1. If you want to send 10 Sol, specify 10. If you want to send 100 Sol, then specify 100, obviously, and hit enter. You will see the error message that's saying the recipient address, XYZ, in this case the Eki address, is not funded. So if you are really sure that you want to add Solana to the non-funded wallet, that means to the wallet that, which does not have Solana yet, you need to specify allow unfunded recipient. So let's do that. You can see it's finalizing, and we have the signature. So let's take the signature, and again, let's use the Explorer. And you can see, I can increase it. You can see that the transaction was successful. This is the signature. This is the unique signature for the transaction. So later on, after, let's say, 1 year, you can find this transaction actually on Devnet, as we are testing on Devnet. And you can see a bunch of important information, for example, timestamp that the transaction is actually finalized, confirmations, you can see the slot number and so on. In this case, what is important is that we funded actually this wallet address with 1 Solana. We transferred 1 Solana to this wallet address. And you can also see that our address subtracted, or 1 Solana was subtracted from our address. You can see these balances also from the CLI. So if I go back and specify Solana balance, that will show balance of the currently set wallet address. That means of the root config Solana ID JSON. So basically my wallet address, which is 3.999995 Sol. Why it is not 4? It is because this the signer or our wallet was also paying transaction fees in order for transaction to be processed. So we sent 1 Sol to the recipient, but also had to pay transaction fees. So that's why we actually do not have 4, but slightly less. But we can also see the balance of the Ekis wallet address. So let's do that. We were sending to, this is the Ekis wallet address, or once again, we can do Solana keygen pubkey Eki in order to see the Ekis address. Obviously, in real-world scenarios, you won't have the JSON file because the JSON file contains private key. So if your friend has some address, you won't know what is the private key of your friend's wallet probably, because if you know the private key, then you can steal his funds. So this is again just the testing scenario where we actually have a private key of both addresses, but in the real world scenario, you will just know his public key, or if he wants you to send him Solana, then he will tell you what is his public key. But in this case, in this testing scenario, we have private keys of both addresses, so we know both public keys. So let's check the balance of the Ekis wallet. We can use Solana balance and specify the Ekis wallet. I just copied the public key. And you can see the Ekis wallet has 1 Sol. So these were the most basic commands you can use in the Solana CLI. Hopefully it made you understand Solana CLI a bit more. So we went through the Solana config get and Solana config set. With Solana config get, or let me clear it first. I have some kind of bug here. Oh, okay, it disappeared. With Solana config get, you can see the config, so you can see what is your default key pair and what is the RPC you are communicating to, or what is actually the cluster you are using. We are currently using the Devnet. We went through also the Solana config set. So for example, if I want to switch back to the mainnet, I can use Solana config set -u, m stands for mainnet. You could see that we used D for Devnet. Then we also generated new key pair. So for that you can use Solana keygen new, and using Solana keygen you can also read private keys. So Solana keygen pub key, or read private keys. Public key corresponds to private key. So if you have generated private key, then you can use that private key in order to generate a corresponding public key. And the public key is actually the wallet address. This might look a bit technical, but I think this is part of the fundamentals of blockchain and also Solana. In order to, you should know basically what is the difference between private key and public key, but as the names suggest, private key should stay private, and public key is something that corresponds to private key and is public. All right, so we went through the Solana keygen new and also keygen pub key, and you could also see Solana airdrop and also Solana transfer. So we were just transferring tokens and airdropping tokens and so on. There are a bunch of other commands that you can use. For example, or maybe I would say these are more advanced commands, or used maybe once you are a developer. So for example, you can see how the Solana works currently. What are the transactions that are sent to the Solana? In that case, as we are set to the mainnet right now, you can see it on this line. We can actually see the logs of the blockchain. So we can see all of the transactions that are processed on the blockchain. So let's check it. Let's check them out. Maybe don't get scared, because these are all of the transactions processed on the Solana. You can see it is a lot of transactions because Solana is actually pretty fast. So there are a lot of transactions processed currently. So I will stop this mess. And yeah, so for example, this might be helpful if you are testing or you are testing locally and you are using local validator. We will learn how to do this later on. And you would like to see the outputs or the process transactions when you are testing locally on your Solana local validator. Then you can also see logs of this local validator. But as I said, we will discuss this later in the later stages of course. These were the logs. You can also check, for example, as we are in the blockchain perspective, and blockchain is created from blocks. You can also see, for example, the latest block. So you can specify, and I will redirect the output to the text file so we can have a better look. Okay, you can see that the new file was created. So let me close the terminal. And this is actually, or these are contents of the latest block on the mainnet. There is a bunch of stuff. I'm not going to go through all of the fields, but you can see some maybe already familiar terms. For example, okay, block time or time should be familiar. Maybe transaction might be familiar. So I was talking about that the blocks in the blockchain contains transactions. For example, on the Bitcoin, this can be more simple transactions like transfers. So Alice sent Bob 10 BTC. But on Solana, these are transactions that contain instructions which are then invoked in the Solana virtual machine, or Berkeley packet filter, BPF. For now, you probably won't be familiar with the output or with the information here, but you can see, for example, here is the instruction 0 that is within the transaction, and you can see it invokes program vote. So this is actually voting instruction or voting transaction. As I was talking about the true TPS, we have something called non-vote transactions and vote transactions. So this is vote transaction. We can scroll down and we can try to look for non-vote transaction. So give me a second. Hopefully I will find something. But okay, there are mostly vote transactions, so I don't want to spend a lot of time on this, as this is system program instruction. Okay, here maybe you can see transaction, some transaction number, and you can see instruction 1. I completely understand that this might be unfamiliar to you guys, but you can see instruction 1, plenty of accounts on inputs. You will learn what the accounts are in the next lessons. But what is important is this program at the start, and I would say it belongs to Jupyter. So there is someone is invoking some instruction that corresponds to the Jupyter program, and you probably know that Jupyter is pretty famous DEX on the Solana with really great volume. So that's just the example of instruction that can be in the transaction. Maybe one important point here, as I was talking about that, transactions can have one or multiple instruction within it. So you can see that we have transaction, and inside the transaction we have instruction 0, instruction 1, and even okay, that was probably all. But important point is that you can have multiple instructions within one transaction. All right, and now just quickly, let's create some meme coin. So this command is going to be pretty, I would say, not complicated, but it will contain a lot of subcommands that might be not familiar to you, but whatever. We will create a new token that will have some kind of picture and so on. We will see it on the Solana Explorer. So why not? But please don't forget that we are on Devnet, so you won't be actually able to to sell this meme token. So let me close this file, and all right, so we are on mainnet. So let me switch to the Devnet. All right, we are currently on Devnet. Just let me check my balance. All right, and on Solana, for example, or if I compare it to the Ethereum, on Solana tokens work quite differently. We have something called SPL token program that manages actually the structure of tokens. So you can come to the CLI, you can call SPL token program, and you can create new token in basically 2 commands. So that is what we are going to do now. You will learn more about the SPL token program, for example, in the handbook, but we also have bonus lecture on the SPL tokens. And yeah, you will understand this in the later stage, or you will understand this more in the later stages of the course. But yeah, let's continue with token creation. So we are calling SPL token. We need to specify program ID currently. That's because currently on Solana, there are, I would say, two programs that are able to manage tokens. First is the SPL token, and the second one is token 2022. The token 2022 is actually extension of the SPL token and adds extensions to the let's say, older version of the SPL token, so to the first version of the SPL token. So in this case, as we are going to create meme token, I want to have a name in the meme token, I want to have symbol of the token, and I want to have URI of the token. So I want to also include, for example, image that is stored somewhere off-chain. So let's do it. I need to specify program ID. This metadata that needs to be specified for the token. So for example, name, URI, and symbol are available in the token 2022. So we need to specify program ID of the token 2022. So let's continue. Now we need to specify the program ID of the token 2022. You have a bunch of options. For example, you can go to the token 2022 docs, and you can see program account address. So let's copy this and paste it here. Now we want to create tokens, so we specify and we want to enable metadata. You will learn that SPL tokens, the old SPL tokens, can have only supply, decimal places, and authority. This was solved by the Metaplex, for example, that is also Solana program that can add metadata to the tokens. But in token 2022, this support for metadata was added, let's say, natively. So I can create native token without Metaplex using the token 2022 program, and I can enable the metadata. So in the metadata, I can then store additional information, for example, name, URI, and symbol. So let's enable the metadata. Really simple. Enable metadata and press enter. It was created with the 9 decimal places. We didn't specify the decimal places, but that can be also optionally specified. By default, it is 9. And this is the address of the new token. So let me copy the address and we can have a look at the Solana Explorer. You can see that again, we are on the Devnet. The current supply is 0, the decimals are 9, and basically the token is empty. We did not specify yet the name, the URI, the symbol, basically anything. So let me add the important metadata. In this case, we need to again talk to or invoke program, which is SPL token, or sorry, call the CLI command, which is SPL token. Now, we would like to initialize the metadata. We enabled the metadata, but we would like to initialize it with some particular fields or inputs that are going to be stored in the metadata. That means the meme token, in this case, have actually the context. So has the name, has the symbol, has the URI. So let me call initialize metadata. And now we need to specify on what token account, or for what token we would like to initialize the metadata. So we created token at this address. So we copy the address and we paste it here. All right. Now we would like to add name to the token. So for example, what should be the name? Season 6. Season 6, all right? Then we would like to add symbol. So hopefully it will work, for example, S6. And we would like to, the last thing we need to add is the URI. So, and in the URI, actually the picture is contained and also some kind of additional information. In this case, I will show you the URI and the contents. So for example, let's use something funny. All right, but I need to check it on the mainnet. So let me switch Explorer to the mainnet. Wait a second. Doc with. Did I doc with? Wait a second. That's strange. Oh, here it is. Doc with hat, right? This is also, we can see this token in the Explorer, and if we navigate to the metadata, we can see a bunch of fields, but we are looking for the URI. So let me copy the URI, and we can see, I can increase it. This is the off-chain part, so on off-chain, on this URI, this is stored actually, all right? So the name, the symbol, description, and the picture, which is stored on the NFT storage. So for example, let's use that. Why not? So I paste it here, and I would say this should be everything. So no, this is not everything. We need to also specify the update authority, which is going to be problematic because I did not store the our public key, but never mind. I can actually create new bash and specify all right, this is our public key. So we can come back and paste it here. And if I press enter, it should work. Okay, it took some time to process, but it worked. And now we can copy the signature. We can go back to the Explorer. You can go to the Devnet, and we paste signature here, right? This is signature of transaction. Okay, so this transaction was only created the metadata. So in order to see the metadata, we need to navigate to the second account, which belongs to the token. And voila, you can see that we have dog with head token, we have the season 6, symbol is S6, and this is the URI as we specified from the meme coin. We have also mint authority. The total supply is 0, but we obviously can mint the new tokens. And yeah, we can see, for example, the decimals. So I was talking about the Solana having 9 decimals. So this is basically the same approach. So let me clear the terminal. And now again, I would like to recap. So firstly, we went through the config and we were using subcommand get, which actually get us the configured, for example, Solana key pair or public-private key pair. For example, the desired cluster that we would like to communicate with. It can be mainnet, devnet, for example, or testnet. It can also be localnet, but localnet is for local testing, so that's why I also didn't include it in the slides. And then we went through also the subcommand stat, which lets you to update these config parameters. So for example, you can, as I said, update the desired cluster, so not mainnet, but you can use devnet as we were using for this token creation. Then we created new accounts with the Solana keygen, or in this case, we created new private keys. Each private key has corresponding public key, and public key is address of an account on Solana. So hopefully this is clear. And we have the default one, and we created also account for Eki where we transferred one sol. Then we used also airdrop, but pay attention, this is only available on Devnet where the Solana tokens are worthless and you cannot sell them to anyone, or you cannot pay by these tokens anywhere. Then, yeah, we were transferring tokens, and last but not least, we created new meme token. We used already created Yuri for the one of the previously launched meme tokens that were successful, but in this case we update the name and the symbol just to show you how you can create, for example, new tokens on the Devnet. As I showed you on the start of this hands-on example, there are a bunch of commands that you can use with the Solana. To be honest, I do not know each of the command, what the command is doing, so, or what can the command do. So you can go through the commands, you can try the commands by yourself, but from my point of view, the keygen, the airdrop, the transfers, and the config set and get are from my point of view as a developer and auditor, these are the most often used commands from the Solana. Also, I think there are commands for deploying programs, but this will be described later in the course. So yeah, from my point of view, this is all from the hands-on example, and we can move to the slides again. I hope you enjoyed the hands-on example and also you enjoyed the first lesson of this school, of this course. I'm looking forward to your next task submissions and to your progresses. We would like to create Solana developers from you guys. So I'm looking forward to it. If you have any questions, I was talking about the tasks, I was talking about the materials, I was talking about the Solana Handbook. If you have any kind of questions, please ask on Discord. It would be best if you can ask in the dedicated channels, so also the questions will be answered faster by, for example, your peers, and also the peers can see the answers. So maybe someone has the same question, but it will already be answered because you asked first. Yeah, so that's everything from this lesson, and see you in the lesson 2. Bye.